In this video, we are going to discuss how to solve a system of linear equations using a method called elimination. So as you know, when we have more than one variable, we have to use a special algebraic approach to solving equations. So the first one was solve a system by graphing. The second method we looked at was solving a system by substitution. And now we're going to look at, again, a method called elimination. So this is going to be broken into two parts. So first of all, we're going to use elimination when both equations are set up in standard form like so. And there's 4 steps. So we're going to add these two equations together. And we want one of the variables to eliminate. And so we needed them to be opposites of each other, like 2x and negative 2x. If we add them together, they cancel out. In the part 2 video, we'll talk about if they're not ready to cancel like this, we might have to multiply one or both of the equations by a constant. So like I said, we're going to add these equations together. One of the variables is going to eliminate. Then we're going to solve for the remaining variable. Once we have that first value of x or y, we then will substitute back in, like we did in the substitution method, and solve for the second variable. So let's look and see what this might look like. So here are our equations. They are set up in standard form. Negative x plus 2y equals negative 8, and x plus 6y equals negative 16. So just as if I asked you to add 426 plus 234, you would add the numbers in the like columns. That's what we're going to do here. We're going to add these up. So negative x and x, they are opposite. So this is negative 1x and 1x here, positive 1x. So if I add them, they cancel. And then 2y plus 6y add up to be 8y. We bring down our equal sign. And negative 8 plus negative 16 is negative 24. And then you would solve for a y. To get y by itself, we will divide both sides by 8. And so the value of y now is negative 3. So the x is canceled. I have a value for y. Now we want to plug this y equals negative 3. We want to plug this back into the top or the bottom equation. It doesn't matter which one. You can plug it into both if you want. You'll get the same answer for x if you're doing it correctly. Whichever one you think looks easier to work with. I'm just going to pick this bottom equation since x was positive. That's the only reason why. Some of you might pick the top equation because those numbers are smaller, and that's fine too. So the bottom equation here is x plus 6y equals negative 16. I need to take this y equals negative 3, and I need to plug it in for the y. So I'm going to get x plus 6 times negative 3, we always plug in with parentheses, equals negative 16. And so now 6 times negative 3 is negative 18. So x, oh, I wrote an equal sign instead of a plus sign. And actually, it's going to be a minus sign because 6 times negative 3 is negative 18. So I'm going to get x minus 18 equals negative 16. So I'd add that 18 over to the other side. And negative 16 plus 18 would leave us with a value of x of 2. So my ordered pair solution is 2, negative 3. Now, remember when we're doing systems of equations, you should always plug this ordered pair back in. Since I just used the bottom equation to solve, I'm going to plug it in up top. So 2 plus 2 times negative 3 is what this would look like. And so 2 times negative 3 is negative 6. And I have a negative x out front here. So negative 2 plus negative 6 is indeed negative 8. So we are good to go with this being our final answer. So let's look at elimination one more time. The x's are 4 and 2. The y's are 3 and negative 3. And 16 and 8 are their constants over here. And we are ready for the basic elimination because 3 and negative 3, they're opposites, the same number, and one positive, one negative. So they are ready to eliminate. So they cancel out. I bring down 4 plus 2, which is 6x, and 16 plus 8 is a positive 24. I divide both sides by 6 to get x by itself, and x is a value of 4 now. And now I can plug back in. I'm going to plug into the top equation this time. So 4x plus 3y equals 16, and I need to plug in 4 for this x. So that leaves me with 4 times 4 plus 3y equals 16. So now I need to subtract 16, trying to get y by itself, so I'm going to subtract 16 from both sides. Cancels over here. I don't really want to say cancels over here. 16 minus 16 is 0. And if I divide both sides by 3, 0 divided by any number is 0. So my ordered pair here would be 4, 0. And let's look at one. Well, let's practice what I preach here. I get my answer. Let's plug it in. So I would take 2 times 4 minus 3 times 0. 2 times 4 is 8. So there is my correct answer because I plugged it into the equation I didn't use and I got the right values. So on this equation, this system of equations, I have negative 2x and negative 2x. They're both 2's, but they're both negative. So we're going to do one step here to get us ready for elimination. We're going to multiply this top equation times negative 1. And that's multiplying by a negative 1 because I need these x's. I want to add them and have them cancel. Right now, if I would have added, I would have got negative 4x and 8y. I still would have had an x and a y, and I couldn't have solved with those. So I'm going to multiply this top equation times negative 1. So negative, and all that does, ladies and gentlemen, is just going to change all these signs. It's going to make them all positive. So I'm going to get 2x. Negative 1 times negative 3 is now positive 3y. Negative 1 times negative 11 is positive 11. So it's like you're going to distribute a negative 1 times each term. Now, this one is gone. Okay, I'm going to undo that. So if anyone's looking at the paper copy, they can see that. But anyway, this top equation is gone. Now I'm ready to add negative 2 and positive 2 now. Cancel like I wanted. 5 and 3 leave us with 8y, and 13 and 11 is now 24. A lot of 24s in this example, or these notes. Divide both sides by 8, and now y equals 3. So again, this was just one example where these weren't opposites of each other. They were the same number, but they were both negative. Now, if they were both positive, you could do the same thing. Just multiply one of the equation times negative 1, so that when you add them, you can get them to cancel out. So to finish out this problem, I'm going to plug into this bottom equation here. The negative 2x plus 5y equals 13. I'm going to take this 3 and I'm going to plug it in for y. And so I have negative 2x plus 5 times 3 equals 13. Negative 2x, 5 times 3 is 15, equals 13. To solve, I would subtract 15 from both sides, and I would get 13 minus 15 is a negative 2. To get x by itself, I'm going to divide both sides by negative 2, and x equals positive 1. So let's check. Our ordered pair here would be 1, 3. So we can plug into this top equation. That would be negative 2 times 1 minus 3 times 3. We want to know, does that equal negative 11? So let's see, negative 2 minus 9. That does indeed equal negative 11. So it looks like we didn't make any mistakes. So that concludes our elimination part 1 video.